Hey, it's Ian here with a bit of Sunday evening fun. Exponential thinking, is it possible for humans? I don't think it is. I don't believe that humans can think exponentially. Maybe there's a savant out there somewhere who can do and understand what maths does in their head, but I've never been able to see anyone who can prove to me that it is possible. So what is it? It's the compounding effect, or the exponential effect, is when something starts to multiply on itself again and again. And as humans, we've evolved to see the results of this in natural phenomena, but not the actual cause of it. So whether it's a small patch of warm ground causing a column of air to rise, starting off in hurricanes and tornadoes, or whether it's a ripple catching the wind on a piece of water that then starts to grow and then eventually becomes a supermassive wave as it starts to bump into other large waves and it grows exponentially. So we can see the end result of it, but we don't understand how it gets there. You can't look at that ripple and say, oh, that's going to be a huge wave one day, because you just don't know. And I'm going to prove this in the form of 3 examples. And when you see them, every time I've asked somebody the question that's coming up now, which is how tall would a piece of paper be if you could fold it 50 times? Well, I tell you what, why don't you just do it now? Try and think to yourself, a piece of paper, fold it in half 50 times. So you just keep folding it in half 50 times. Now, we all know you can only fold it 7 times. I'll show you that in a moment. But how tall would it be? A meter? A bus? The Eiffel Tower? I don't know. You think yourself. And just remember that answer, because I'm going to prove just how crazily tall it gets. And then there'll be the grains of rice on a chessboard, which is an old story from many years ago. And I'll apply the same thing to grains of sand on a chessboard, which is even more mind-blowing. Okay, so I'm now going to switch over to a short video I did. And here you can see I'm folding the paper in half, and I'll try to do this up 7 times or more. Now what actually happens is that on a piece of paper, which is like that, that is 1/10 of 1 millimeter. So if I could fold it 10 times, it would be 1 millimeter thick, right? If I had not fold it 10 times, 10 of it would be 1 millimeter. And as you can see, that's 6 folds, and I can't get it to go anymore. It's almost impossible. No, one more, sorry, that's the 6th fold. I couldn't get it to 7, and the reason is because as that stack grows, it doubles in size every time, and the outside piece of paper has to not only cover the outside and the underside, but also the height there as well, which is why you can only fold it so many times. This is such a crazy idea that the Mythbusters themselves tried to prove that you could do it more than 7 times. So they got a ridiculously large piece of paper and a very thin paper in a large hanger, and I'll skip through this. And basically what they did, they got a massive roller at the end to try and squash it down to keep folding it. So they're keeping going, they're keeping going. I think at this point they're somewhere around about the 6th fold. So that entire piece of paper now has only been folded 6 times. Get the roller out, and they now try and roll it. I think actually that was maybe in the 7th, because now what they do is at the end is they try and get it down one last time, and they just can't get it more. And that, I believe, was the 8th fold. So the 7-fold myth has been broken, but they can only do it 8. And that's with a piece of paper that size, incredibly thin, and with a huge great big roller. So here's the proof. I've got a piece of paper that's 1/10 of 1 millimeter thick, so we know how tall it's going to be by the number of layers of paper would be if you could fold it 50 times. It doubles, there's a factor, it doubles every single time you fold it. And what we found is that on the 51st fold, so not the 50th technically, on the 51st fold, it overshoots the sun by 75 million kilometers. So on the 50th fold, it got all the way, or so it got 3/4 of the way out to the sun. And again, it's because it's doubling every single time. And I bet you your answer wasn't to the sun. I think my answer at the time was it was going to be something like the height of the Eiffel Tower, something crazy. And I thought I was being utterly ridiculous when I said that. And the evidence is right there for you. You can calculate that yourself. So the compound effect, that's what it is. That's why Warren Buffett makes so much money by having something small that just lets time keep adding on top. So it's interest on interest on interest on interest that just keeps doubling up on itself. So the interest you earn has interest applied to it, so that's accelerates and accelerates. And then suddenly you go through this what's known as a power law, which goes just suddenly, it just goes crazy. Because the last fold, the 50th to the 51st fold, that added 75 million kilometers. And then it just gets even more crazy. Okay, so there's an old story about a guy who did a favor for I don't know, was he a king or an emperor or whatever it was, and was offered money in exchange for that job he did. And he said, no, I don't want money. I want 1 grain of rice to be doubled every time it's put on a chessboard. There were 64 squares on chessboard. So on square 1, there's 1 grain of rice. Square 2, 2. Square 3, 4 grains of rice. And on square 4, there are 8. And so on until you've gone around the chessboard. And of course the king said yes. But actually what happened was the king would have wished he'd paid any amount of money instead of. Because if there's 64 squares on a chessboard and you've got rice in 1 cup is about 7,000, which means grains per pound is about 29,000, pounds eaten per year by the average Asian. So I picked a completely, just a stereotypically rice favouring person, about 300 pounds a year. And it so happens that not even on the end of the chessboard, but on line 54, so on square 54, which is in, and there's a whole line left to go, you've got more rice than is eaten by 4 billion Asians for a year. So that's India, China, and all the rest of Asia. That's all the rice they can eat in the year today. Now, no one knows where this story came from or if it even happened, but you'd have assumed it would have been a long, long time ago before there was that much population. So, goodness knows how many years of rice that would have lasted back then. But that is a lot of rice. And that's not even the whole chessboard. That's just getting up towards the second to last row. So then I thought, well, let's find something even more ridiculous. Let's find something smaller than a grain of rice and calculate what it would be if it was sand. So of course there's a website out there where someone has tried to estimate the total number of grains of sand that exist. And we know that roughly what a grain of sand size is. We know the approximate average depth of deserts. It's not actually dissimilar ever. There's a lot of consistency. Sand can only stack so high. So it will only ever be so deep in a desert. We know the approximate coastlines around the world, and someone's gone out and measured it. Now, they may have got it completely wrong, but when it's completely wrong, you're still not going to be prepared for this answer. Because as an absolute coincidence, and there it is, you can look at npr.org blogs, you can see the URL, you can get that URL for me there. On the 64th line, you'll have got more, which is 64th square, sorry, that's the last square on chessboard, more grains of sand there than there are in all the deserts and beaches on planet Earth. And that's just 64 times itself. So that's 1 grain of sand doubled 64 times. And that's where it gets to. So for the number of times I've bored people to death with this in some kind of social setting, and they start shouting at me and calling me whatever, this is the proof, and you can build it yourself. It's not difficult at all. And this goes towards proving that if you ask anyone any question at all about compounding effects and what they have, they will never be able to imagine it in their minds without using a spreadsheet. Not even a calculator, because calculators don't even have that number of digits on them in the end. Tried it. So we cannot, as humans, think exponentially. The natural phenomena we see are the results of compounding effects, but we can't predict. We can't predict from the small things we see in our lives what's going to happen when those things start to compound. Is there a lesson in all of that? I don't know. You draw one yourselves. I believe there are lessons, because the final thing is we are going through a period now where that curve has just started to happen in technology. We're just beginning this. Up until now, stone tools, etc., just building up. So it's tools enable you to build more tools that enable you to build more tools efficiently, and then there's multiple different types of tools building different types of tools that make other tools faster. And we're just beginning to see this curve now. And the first quantum computer was bought just a few years ago, and I believe Google's just announced that it's now got its first quantum computer being used. That they've been privately owned up until now, I believe, quantum computers on the whole, and that's going to make this look ridiculous. So any amount of computing power you think someone's got today, just forget about it completely, because already Google's can now, or anyone with a quantum computer, can do the number of calculations of all the computing power that's ever existed on the planet Earth, and they can do it in about a minute or less. So the tools we've got are accelerating, and as they accelerate the growth of other tools. So it's like one wave colliding with another wave to make a wave much, much bigger. And then waves just all keep adding on to each other, so they get really big. And there you go. So if there was a conclusion or anything to draw from it, is expect a ridiculous amount of change in the very, very near future, because our tools are now building tools. There you go. Thank you very much.